Okay, the final thing that we'll talk about are memory leaks and dangling pointers. So a memory leak is when you have reserved space in memory, but there's no way to access it. So it's just wasting space. It's taking up a bunch of stuff in memory that you can't ever get to it again. So there's no reason to have it. So it's wasteful, right? You prevent memory leaks by freeing up your dynamically allocated memory when you no longer need it. So how do I dynamically allocate memory? With the keyword new. How do I free up dynamically allocated memory? With the keyword delete. Okay? That's how you avoid it. Almost the opposite of that, I mean, not quite, but almost like the inverse of that is a dangling pointer. A dangling pointer is when it's not that I can't get to it. I have access. I have a pointer and it's pointing to a place. It's just there's no reason for me to be doing that because there's nothing stored there. So it's like a pointer that points to nothing. That's a dangling pointer. There's just garbage there in memory. So like I'm saving the address, but why? You can avoid them by setting a pointer to null when you're done using it. So you're saying like, this memory has been, okay, so here we go. There we go. This memory has been deleted. It no longer stores any valid information. So I will set the pointer to null and then it will no longer store an address. Okay, so at first I got memory, I used it, and then I want to delete the memory and set my pointer to null. Now the pointer has nothing, which makes sense because it wasn't pointing to anything anyway. So why not set it to null? And then here's the thing you have to be careful about. If a pointer is null, if it does not have an address, do not try to use your little asterisk with your pointer name because asterisk tells it, go to this address and get the value stored there. Well, how does that make any sense if there is no address? If you set your pointer to null, right? I'm telling it, oh, I want you to go to this address and give me what's stored there, but there's no address. So when the computer tries to go to the address that doesn't exist, it's going to give you an error. You'll get that null pointer exception. Okay. So what kind of questions could you see on a quiz or an exam about memory leaks and dangling pointers? If I give you a small code block, I could ask you to kind of like draw pictures, show me what's happening. And that's going to be what I'm looking for there are like those little boxes with the arrows, kind of like we drew in class. And that's going to be similar to that handout that we did. I think on that same first day, it's on the back of, it's on the other side of that predicting the pointers handout. So we did it the very first day that I introduced pointers, where we have like little boxes and little arrows, and we talk about what it's pointing to using little boxes as well. And then given a code block, I could ask you, is it a memory leak or is it a dangling pointer? Okay. And I could ask you whether or not a block of code would actually have an output or if it would give me an error, if it's an invalid chunk of code. So you'd need to be able to kind of like trace the code a little bit and understand what would happen, what the output would be. So how could you possibly maybe get an error? What sort of errors should you look out for? The data type mismatch would throw an error. Trying to giving like a pointer, creating a pointer, but not using that address of, just giving it like 4 or like X or something like that. That would be an error because a pointer has to store an address. If you try to access the value from a null pointer, that would give you an error, a null exception error. If you try to delete on some variable that you did not create using new and delete go hand in hand. Create dynamic memory, take it away. it doesn't make sense for me to tell it to use delete on something that was not created dynamically. I wouldn't do that for something that like had a variable associated with it or something like that. So I'll show you just a little bit of code examples of what I'm talking about with memory leaks and dangling pointers, and then we'll be done. So here I have, I'm gonna just take this chunk out. Okay. So now here are some examples of some problems, right? I've got some code here that's like bad code. So I have two pointers that point to strings, and you'll notice that they use the new keyword operator. So this is dynamic memory, dynamically allocated memory. And then here I gave them a value. So I said, go to that address. I am changing the value that's stored there. I have that indirection operator. So I put a hi in one and a goodbye in the other. And here, everything is fine. Everything is happy. Just print them out. Okay. So this is just like what we did at the very beginning of the slides. And I'm going to clear this and we'll see what we get. Okay. So I printed out the addresses and I printed out the values. So I got a hi and a goodbye with a couple of hexadecimal addresses. Cool. I used the reserved word delete. Sorry, I had an interruption there. Okay, so I can, a lot of people think that this is deleting like the pointer itself. It's not. The pointer still exists, right? So I still have access to say like, you know, the pointer is here. And if I run it, I can see that I still have the pointer, right? Look, this is still there. The problem is if I say, well, what is stored there? Let me try and access what is at that location. This does not make sense. I have deleted. I no longer have that memory like reserved for me. I'm asking the computer to access memory that I don't have access to. I'm not allowed to try and access it. That is a segmentation fault, right? Bad instruction. So that would be an example of a dangling pointer where this guy right here, PTR2, is still a pointer. It still exists. It's here like taking up space, but there's no point to it at all because it points to nothing, okay? And the way that I would avoid that, the way that I would like have that not like still be here storing this address for no reason would be to set PTR2 to null, right? A null pointer says that I don't point to anything anymore, okay? So now I'm going to take that out. We're going to see an example of a memory leak. So here we have a memory, okay, yeah. I don't think I need that one anymore because I have it here. Okay, so here I have, I'm saying take the address of PTR3. So this is the address of PTR3. And I'm saying store it in PTR2. Store it in PTR2. So now PTR2 has been overwritten and it has the same address and it points to goodbye. So I don't like that that goes to a new line when the other ones did not go to a new line. So I'm just going to take that out so that it will look more uniform like the one that came before it. And that was a mistake because I do need to separate it with a space. All right, let's try that again. Much better, much better. So see that I overwrote it, but what happened to this guy? He's still hanging out. He's still out there. I never released this memory. So this computer is still remembering hi. It's still like saving that for me somewhere. And it's pointless because I can never get to it again. The only way I had access to high was that it was the location that pointer 2 pointed to. That was a tongue twister. And now that pointer 2 does not point to it anymore, because now pointer 2 points to goodbye, high is lost forever. So that would be an example of a memory leak. And, you know, I mentioned that we can try and change like the values that are stored, but we are not allowed to change the memory locations of where it's stored. So some people might be like, oh, well, I know where the address is. I have the address right here. I'll go back and retrieve it, and then it won't be a memory leak anymore. You can't do that. You can't, you as the programmer are not allowed to say, this is an address and I want to store it in this pointer. And it's like it has the red angry lines. And if you say like, well, what's the error that it's giving you here? I'm trying to hover over it so that it will show, but it's not giving me a pop-up. But basically operating systems are what like decide where things get stored. So you can't do that. Okay. That's it. That's all that I have. Hopefully you feel better about pointers, and you feel like if you go through and look at these questions that I might ask, you feel like you would know how to do them. And if you do not feel that way and you have any questions, by all means, please just email me, or maybe next Monday, go to like the SI group tutoring with Allie or something like that. And I hope you have a good weekend, and I will see you next week.